Hey everyone, happy Thursday. Hope you guys are having a great day so far. I am not at school today, so I thought I'd make a little video describing what you are going to be doing today. Yesterday we did the lab. Turned out pretty good. A lot of groups got good data. Today's focus is on covalent compounds, and what we're going to be doing is we're going to be drawing covalent compounds, but now we're going to be looking at 3D shapes of covalent compounds. So, what I'm going to do is I'm going to go through our day 4 notes. Our day 4 kind of introduces the shapes of each molecule. All right, so I'm going to show you day 4. I'm going to pull that up here real quick. And what it's going to look like is this. All right. Hopefully you all are able to see that. All right. We're going to make this presentation mode. Okay. So what we're going to learn new is what's called VSEPR. I call it VSEPR, and it introduces the different shapes and geometry that the formulas are going to make. So we're going to make this into real life. And I'm going to kind of go through this fairly quick. These notes are posted in Google Classroom. So if you need to catch up or anything, you can pause the video or go to Google Classroom. Okay. So geometry. All right. VSEPR is all about this geometry idea where the electrons are going to form shapes when bonds are made. All right. And that's the whole idea of either shared or unshared electrons. All right, they're always going to go as far away from each other as possible. It's the repulsion theory, right? They're repelling each other. All right, and when they do repel each other, what happens is they get shapes. All right, so a couple examples here. First one is linear. Linear is going to be the first shape. That occurs when there's 2 atoms, looks something like that, or 3 atoms, and looks something like that. Where in this case, the central atom must have no unshared pairs of electrons. Okay. Good example of that is CO2. Okay. Next one is known as bent. Bent has 3 atoms. All right. The only difference on this one is that the center element has lone dots. You see that? Let's slide that over there. The center atom has lone dots, and that will make a bent shape, like water. All right. Okay. A little H2O. And there's its degree. All right, next is trigonal planar. Trigonal planar looks like 4 atoms. All right, where there's no shared electrons in the middle. There's double bond. All right, and looks like that. Now, what you can probably guess is the next one is trigonal or pyramidal. Pyramid is the same thing, 4 atoms. However, once again, the key thing here is the dots in the middle. Once again, we hit the dots. Central atom has 1 unshared electron. That's going to create a pyramid. All right, so what we're going to be doing today is we are going to build these different molecules. All right, so a pyramid has, let's say, a lone pair of dots. All right. So it might look something like it has 3 bonds, a lone pair. Might look something like this. Right? Kind of looks like a pyramid, right? So what we're going to be doing today is we're going to be building molecules like that. Pretty cool. Pretty cool. All right. So pyramid, 4 atoms, 1, 2, 3, 4, where the lone is. The center has an unshared pair. All right, tetrahedral, 5 atoms, 1, 2, 3, 4. Middle has no unshared pairs. next, we're going to get into some unique ones, all right? Trigonal bipyramidal, it's very rare, very unique, but I feel like it's pretty important to talk about. There's 6 atoms. You might be wondering, like, is that even possible? Well, it is possible. It's one of the exceptions on the periodic table. And it's impossible to build. We're not going to be building it. But I just thought it's pretty important to show you that having 5 bonds, if you count 1, 2, 3, 4, 5, it is possible. Right? Only in these circumstances, if you can look down at the bottom left, for elements in period 3 and higher, when bonded to fluorine or chlorine, it can be possible. Okay. So here's an example of what it might look like. Looks kind of crazy, but it is possible. All right. And the last one is, oh, that was the last one. Okay. So here's a summary of all the shapes. All right. Linear, flat across. Bent, that's a bent shape. Trigonal planar, pyramid, tetrahedral, and trigonal bipyramidal. All right. So what you're going to do is you're going to be building these molecules. You got the worksheet. You're going to be golden. You're going to be building these molecules. You're going to see what they look like in a three-dimensional figure. It's pretty cool. Pretty cool. I wrote some helpful tips. All right. The black makes 4 bonds. All right. So if you're trying to make 4 bonds, use the black. The blue makes 3 bonds. If you're using blue, makes 3. Red makes 2, and all the others, yellow, orange, green, purple, all of those make 1 bond. Okay? So have a little fun. Draw some structures, build it, try your best coming up with the names for each molecule, and have some fun. Hope you guys have a great day, and we'll see you later.